Today we're going to be taking a look at topic 1.7, which is on integral exponents. Again, let's take a look at our learning targets. By the end of this lesson, you should be able to express a power with negative exponents as a power with only positive exponents. You're also going to be able to use exponent laws to simplify expressions and solve problems involving powers or radicals. So when we're talking about integral exponents, we're talking about both positive and negative exponents. So let's take a look at some patterns here. We have 2 cubed. 2 cubed is 2 times 2 times 2, which is 8. 2 squared is 4. 2 to the 1 is 2. And 2 to the 0 is 1. Now if I put 2 to the negative 3 in my calculator, that's going to give me 0.125. And if I convert that to a fraction, that's 1 over 8. Now 2 to the negative 2 is 1 over 4, and 2 to the negative 1 is 1 over 2. Now if we look a little bit further, 1 over 8 would also be the same as 1 over 2 cubed. 1 over 4 would be 1 over 2 squared, and 1 over 2 is the same as 1 over 2 to the 1. So when I have a negative exponent, all it's asking me to do is change the position that my base is in. So for example, if I had 3 squared, that would be 9. If I had 3 to the negative 2, that would be 1 over 3 squared, which is 1 over 9. Now, if I were to write that as a general rule, I could say that x to the negative m is the same as 1 over x to the m. The reverse of that, 1 over x to the negative m, would be x to the m. So notice if I have a negative exponent in the numerator position and I move it to the denominator position, the exponent becomes positive. If the negative exponent is in the denominator, moving it to the numerator will make it positive. Now, a convention in math is that we always write our final expression with only positive exponents. So you're going to see that we need to use this quite often. Example 1 asks us to write each of the following expressions with a positive exponent. So 2 to the negative 4 would be 1 over 2 to the 4. And if I was asked to evaluate, I could go one step further and write 1 over 16. 3 to the negative 7 would be 1 over 3 to the 7th. Negative 2 in brackets to the exponent negative 3. Well, the negative 2 is going to stay in brackets, so it's going to be 1 over negative 2 to the power of 3. And again, if I'm asked to evaluate, I could go one step further. 1 over 3 to the negative 2 would be 3 squared. Now for e, we have 3 over 4 to the exponent negative 2. And if you remember our exponent laws, we're able to bring this 2 in and distribute it to both the 3 and the 4. So that's going to give me 3 to the negative 2 all over 4 to the negative 2. Because 3 has a negative exponent, I'm going to move it to the denominator. Since 4 has a negative exponent, I can move it to the numerator. So that's going to give me 4 squared all over 3 squared. Another way to do that is to just flip the fraction. So I can change the 3 over 4 to 4 over 3, and that will automatically make my 2 positive, and then I can distribute afterwards. So that would give me 4 squared all over 3 squared. So we can flip first and then distribute, or we can distribute and then flip. All right, so there's a few more examples there. I'm going to ask you to pause the video, try them on your own, and then come back and check your answers. So let's take a look at our answers. We have 2 over 5 to the exponent negative 3. What I've done is I've flipped my fraction, so I now have 5 over 2. By flipping my fraction, I've also changed my exponent from a negative to a positive. So my final expression would be 5 cubed over 2 cubed. For g, I have 1/2 to the exponent negative 3. So again, flipping that fraction will give me 2 over 1 to the exponent 3. When I distribute, I'm going to have 2 cubed over 1 cubed, which just simplifies to 2 cubed. 2 to the negative 3 is 1 over 2 cubed. 1 over 7 to the negative 2 is 7 squared. And 1 over 3 to the negative 4 is 3 to the 4th. Now with this example, we are not asked to evaluate, so I've left them in exponential form. Quite often you're going to be asked to write in exponential form first and then evaluate as your final step. So for example, 1 over 2 cubed would be 1 over 8. 3 to the 4th would be 81. For example 2, we're asked which is greater, 2 to the negative 3 or 3 to the negative 2, and we're asked to justify our reasoning. Well, 2 to the negative 3 can be written as 1 over 2 cubed, and 3 to the negative 2 can be written as 1 over 3 squared. So 1 over 2 cubed would be 1 over 8, and 1 over 3 squared is 1 over 9. So if I ask myself which one is bigger, which would be bigger, 1/8 of a pizza or 1/9 of a pizza, 1/8 would be bigger. So that means 2 to the negative 3 is bigger. So let's take a look at some more examples. When we're looking at negative exponents, what's really important is that we pay attention to what the exponent is applying to. We only have to move the pieces that have negative exponents. So here I have 3 times a to the negative 2. So that is 3 times a to the negative 2. The negative 2 is only applying to the a, so it's only the a that needs to move. The 3 stays locked in place. So this becomes 3 over a squared. When we look at b, the negative 2 is applying to the entire expression 3a, so this is going to be 1 over 3a all squared, and then I can distribute that 2. So I would have 1 over 3 squared, which is 9, so I'd have 1 over 9a squared. So I have 1 over a to the negative 5. Since the negative 5 is only applying to the a, the 1 stays put, so I'm going to have 1 times a to the 5th. Multiplying by 1 doesn't change anything, so I can just write this as a to the 5th. Now for d, I have negative 3a over b to the exponent negative 2. I can distribute that negative 2 first, or I can just flip my fraction, so I will have b over negative 3a to the exponent 2. Notice I didn't change the signs of anything in the brackets. By flipping it, I'm just changing the sign of my exponent. Now I can distribute, so I would have b squared all over negative 3 in brackets squared and a squared. Simplifying that would give me b squared all over 9a squared, because negative 3 in brackets squared is a positive 9. So in example 3, we're going to simplify using exponent laws, and then as a final step, we're going to make sure that all of our exponents are positive. When we're working with integral exponents, typically it's easier to just wait until the end to worry about whether exponents are positive or negative. So simplify everything like you've been doing all the way along and worry about the negatives at the end. So we have m to the negative 4 times m to the negative 5. That's going to be m to the negative 4 plus negative 5, so m to the negative 9. I've got it fully simplified. Now I ask myself, are there any negative exponents? There are, so I go one step further and I change this to 1 over m to the 9th. For b, we have x to the 3 divided by x to the 7th. Well, 3 minus 7 is x to the negative 4, and then I can convert. Now, I do a bit of a shortcut sometimes with division. I'll look and say that 7 is bigger than 3, so I know that my final answer is going to have an exponent in the denominator. So I might think about this as dividing or subtracting in reverse. So if I think about this as x to the 7 minus 3, I'm going to have x to the 4th, but since 7 was bigger than 3, my 4 is in the denominator. P squared to the exponent negative 3, well, we're raising a power to a power, so we're going to multiply. That gives me p to the negative 6, and when I rewrite that as a positive exponent, I'm going to have 1 over p to the 6th. For d, we need to distribute. Again, remember that's like having 3 to the 1. So we're going to have 3 cubed times x cubed times y to the negative 6. Looking at my expression, y is the only term that has a negative exponent, so the rest stays put. 3 cubed is 27, x cubed, and then the y is going to move to the denominator. For e, we're going to combine my multiplying, so we have negative 2 times negative 6 is positive 12, a to the 1 times a to the 4th is a to the 5th, and b to the negative 3 times b to the negative 2 becomes b to the negative 5. So it's important to note here that we're not distributing, we are just multiplying like terms. So we have negative 2, which could be written in brackets, times a times b to the negative 3 times negative 6 times a to the 4th times b to the negative 2. So there are no adding or subtracting signs here, so we're not distributing, we are just multiplying like terms. So our coefficients get multiplied and our like variables get multiplied. Now I have 12 a to the 5th times b to the negative 5. The 12 and the a to the 5th are already positive exponents, so I only have to move the b. So now we have 12 a to the 5th over b to the 5th. For f, we're going to simplify first and then worry about the negatives at the end. So we have a cubed, b to the negative 2, nothing needs to change there. In the denominator, we have a to the 1 times a to the 5th, which is a to the 6th, and b to the 4th times b squared is b to the 6th. Now we have a cubed over a to the 6th, so that's going to be a to the negative 3. We have b to the negative 2 over b to the 6th, so negative 2 minus 6 is negative 8. This gives us two variables with negative exponents, So we're going to have a cubed in the denominator and b to the 8th in the denominator. Well, we can't leave that empty at the top, so we're going to have a 1. So 1 over a cubed times b to the 8th. Again, using that shortcut I had talked about earlier, I noticed that a to the 6th is bigger than a cubed, so I know that my final expression is going to end up in the denominator. So a to the 6 minus 3 is a to the 3. I know that 6 is bigger than negative 2, so 6 minus negative 2 is 6 plus 2, which is 8. So we're going to have b to the 8. And again, if we have everything in the denominator, there has to be a 1 in the numerator. Now, as you saw in topic 1.6, these exponential expressions can get quite complex. And so I'm giving you 3 examples here as an extension. What I would encourage you to do is pause the video, try them on your own, and then come back and check your work and work through them at whatever pace you need to. Also know that there's more than one way to simplify these, so I may choose to break it down in a different way than you, but in the end, we should all still be getting the same simplified expression. So for this first example, we have 12x cubed y to the negative 1 divided by negative 8 times x to the negative 1 y to the 5th, all to the exponent of negative 2. Now you can choose to distribute first, you can choose to simplify first within the brackets, you can also choose to flip. I am going to flip this first to make my negative 2 positive. So I'm going to have negative 8 x to the negative 1 y to the 5th, all divided by 12 x cubed y to the negative 1. And because I've flipped my fraction, that's going to make my exponent positive. What I want you to notice is that when I was flipping those terms inside the brackets, I didn't change the signs. So x to the negative 1 in the denominator is still negative 1 in the numerator. If I were to change those signs and change the outside, then I've essentially been double dipping and I've been changing the question itself. So we have negative 8 divided by 12. If I divide both of those by 4, I'm going to have negative 2 over 3. So that's going to give me negative 2 x to the negative 1 y to the 5th all over 3x cubed y to the negative 1. And again, this is all in brackets with an exponent of 2. I could have simplified my variables at the same time, but I'm just trying to simplify as I go. So I'm going to have negative 2 x to the negative 1 divided by 3. So negative 1 minus 3 is negative 4. And then I have y to the 5 divided by y to the negative 1. So 5 minus negative 1 is 6. And in the denominator, I still have a 3. Once again, I still have that exponent outside. So I'm going to bring that 2 in. Negative 2 squared times x to the negative 8 times y to the 12, all divided by 3 squared. Negative 2 squared is 4, so we have 4x to the negative 8, y to the 12, all divided by 9. Now I've simplified as far as I can. My last step is just to check to see that all of my exponents are positive. And I do have one that is not positive, so I'm going to move that only. I'm going to have 4y to the 12 divided by 9x to the 8th. Now, while these examples are a little bit more complex, I can still check my work using substitution like I've shown in previous lessons. So we can sub in values for x and y in our original expression, sub in those same values for x and y in our final expression, and we should get the same decimal. So even with ones this complex, there's still a way to check your work and make sure that you've done it correctly. Moving on to example 2, we've got, again, quite a complex expression, and we're just going to break it down piece by piece. So I have the 49. I noticed that the piece in brackets here is put to the exponent negative 2, so I'm going to flip that. I'm going to have y to the negative 3 times z, all divided by 7, w cubed, x to the negative 5, z to the 4th, and then all to the exponent of 2. Notice again that as I'm flipping those pieces in the brackets, I am not changing the signs of the exponents. Now that's multiplied by 14. X to the 4th, z to the 8 is all put to the exponent of 0, so that is equivalent to 1. So I don't need to do anything with that. And then on the bottom, I have x to the negative 8, z to the 8. Again, I don't want to worry about those negative exponents until my last step. So we're going to do some distribution. Remember, with order of operations, we have to deal with brackets first, then exponents, then multiplying and dividing, and then adding and subtracting. So I'm going to have 49 times w to the negative 6, z squared. In the bottom, I have 7 squared, which is 49, w to the 6th, x to the negative 10, and z to the 8. And that's all being multiplied by 14 all over x to the negative 8 and z to the 8th. So when we're combining these, essentially we're just multiplying everything on the top and multiplying everything on the bottom. Now if you notice here, 49 over 49 is going to cancel, so that's going to leave me with 1. So on the top I have 14 w to the negative 6 z squared, and on the bottom I have x to the negative 18 w to the 6 and z to the 16. Combining again using exponent laws, I still have 14 on top. W to the negative 6 divided by w to the 6. So negative 6 minus 6 is negative 12. I have z squared over z to the 16, so that's going to be z to the negative 14. And on the bottom, I have x to the negative 18. I have this fully simplified. My last step again is just to check that all of my exponents are positive. So notice that my x is going to move to the numerator and my w and z will move to the denominator. So I'm going to have 14x to the 18th divided by w to the 12th and z to the 14th. And our final example. So here I have an expression to the exponent negative 3, and in the denominator I have an expression to the negative 2. So the 10 is going to stay put. I'm going to move that denominator expression to the top, which is going to be 8 p to the negative 3 q to the 5 r cubed all squared. And I'm going to move the negative expression in the numerator to the denominator. So we're going to have p cubed, q squared, r to the 0, and then to the exponent 3. Now I'm going to distribute, so I've got 10 times 8 squared times p to the negative 6 times q to the 10 and r to the 6th. In the denominator, I have p to the 9, 3 times 3 is 9, q to the 6th, and r to the 0. Now I really don't have to write that r to the 0 because that's just equivalent to 1, but we've got it there just so you can see it's been distributed. Now 8 squared is 64 times 10 will be 640. P to the negative 6 over p to the 9. So negative 6 minus 9 is negative 15. Q to the 10 divided by q to the 6, so q to the 4. And then 6 minus 0 is 6. Again, my final step is just to make sure that all of my negatives are taken care of. So I'm going to have 640. Q to the 4th is positive, so it will stay. R to the 6th is positive, so it will stay. And p to the 15 will move to the denominator. Now, if I take a look at shortcuts, here I have 10 times 8 squared, so that's 640. But when I'm looking at my exponents, p to the 9 is bigger than p to the negative 6. So I could think about this as p to the 9 minus negative 6, which is p to the 15. And knowing that the 9 was bigger than the negative 6, I could automatically put it in the denominator. Here, q to the 10 is bigger than q to the 6, so I'm going to subtract 10 minus 6, but my answer will end up in the numerator. And then 6 is bigger than 0, so r to the 6 minus 0 will give me r to the 6th, and it will be in the numerator. So there are ways that you can do this in your head without having to write it all negative and then flip it, but it's important that you at least show enough of your work that we can see what your understanding is. All right, so those are all the examples I have for you today. Hopefully this gives you a good understanding of integral exponents. Remember that often it's easiest to simplify first and then worry about the negatives at the end. But if you do it in a different order and you're still coming to the same final expression, you should be good. Just follow the rules of math and you'll be good. All right, have a great day, guys. See you soon.